Part 5 of Module 2, this is where we're going to lay the foundation to really begin to interpret rhythm strips. And this is a very, very important part of this class. And we want to make sure that we hit these objectives and that by the end of the lecture, by the end of the class, you have mastered these objectives. We want to make sure that we can recall the general rules to use when correctly identifying heart rhythms. Describe the basic approach to interpretation of EKG strips. Discuss the 5 steps used in interpretation of EKG strips. Explain how to calculate heart rate given a 6-second strip. And we're also going to discuss the causes of artifact on your monitor. First and foremost, always look at your patient. Make sure that you're taking care of your patient. Your monitor is a diagnostic tool that will be very helpful in your patient care, but you want to make sure that you are looking at your patient. Read every strip from left to right. Remember, it's calibrated so that it will essentially read the same way no matter what monitor you're getting your strip from. Apply the 5-step systematic approach that you'll learn in this chapter or in this lecture and avoid shortcuts and assumptions, especially when we're getting into some of the strips where they're very unique and it's going to be very easy to just look at it and say, hey, that looks like a atrial flutter, or that looks like a ventricular tachycardia, and you very well may be correct. Most of the time you will be correct, but we want to go through all the steps just to make sure that we don't miss anything. A quick glance in the strip will often lead to an incorrect interpretation. That goes back to what I was just mentioning just a moment ago. Ask and answer each question in the 5-step approach in the order that I'm going to present. That way you are consistent. No matter what, when you're interpreting rhythms, you want to be consistent. You want to master the accepted parameters for each dysrhythmia and apply them to each of the 5 steps when analyzing the strip. So I'm going to add one extra step in this, which is not actually going to show up here on the next 5 steps, but the very first NICS approach is make sure that you are reading within a 6-second time frame. Now, sometimes the strip that you may get to interpret is longer than 6 seconds. And so we want to make sure that we're reading within the 6 seconds. Remember back from the reading the EKG graph paper, you want to make sure that that we're looking at 30 small boxes across the strip there, and we're only interpreting what's inside of those 30 boxes. So your first step is heart rate. That's going to be really how fast the heart's beating, how fast or how slow. Heart rhythm. Now, we're not talking about the interpretation of the rhythm. We're not, in step 2, we're not going to say, hey, this is a sinus rhythm or a sinus bradycardia. What we're talking about is the actual rhythm or the beat of the rhythm. Is it in syncopation? The P wave, just as I described in one of the previous lectures, we want to make sure that the P wave is uniform, upright, and it's looking like the rest of them on the strip. The PR interval is got to be measured 0.12 to 0.20. If it's outside of those parameters, then it's either a shortened PRI or it's a longer PRI, which could indicate a first-degree heart block. And then your QRS complex, we want it to be sharp. We want to make sure that we're identifying the waves of the QRS complex, and we are wanting to measure the QRS complex, and it should be 0.12 seconds or less. So step 1, the heart rate. The number of electrical impulses is represented by the PQRST complexes conducted through the myocardium in 60 seconds or 1 minute. Now remember, anytime you see a PQRST, as long as the electrical system and the mechanical system are working together, anytime you see a QRS complex, that will produce a pulse. Your atrial rate is going to be counted by counting the number of P waves in the 6 seconds and multiplying by 10. And your ventricular rate is counting the number of QRS complexes noted. It's going to be important for us to do an atrial and a ventricular rate on several of these rhythm strips that we're going to learn in the future so that we can answer some of the questions that we're about to discuss. So a couple of terms here. Bradycardia indicates a heart rate less than 60, so 59 and below. And then tachycardia would be 100 or greater. So the 6-second method. 6-second method is very easy. So you want to make sure that you are You want to make sure that your strip is a 6-second strip, and you count the intervals and multiply by 10. So as you notice here on this sample, you'll see these lines here. So when the strip actually prints out, you'll have these lines. And so from one line right here to the next line right here, that is going to be 3 seconds. And then from right here to right here, that's another 3 seconds. So this would be a 6-second strip. So I'm going to actually count all of the complexes that I see in this 6-second strip. Now, in order to get my atrial rate, I'm going to count my P waves. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So that gives me an atrial rate of 80. My ventricular rate, I'm going to count all of my R peaks. 1, 2, 3, 4, 5, 6, 7, 8. So that's also 80. So what that tells me is going to be an answer to one of the questions we're going to talk about very soon. Do I have a P wave for every QRS, and do I have a QRS for every P wave? And the answer is yes, because both of my rates are the same. So my heart rate for this strip right here is going to be a ventricular rate of 80, an atrial rate of 80. There's another way that we can determine heart rate, and this is the R to R. This can only be used in a rhythm that is regular. You cannot use this method in a rhythm that is irregular. And so what you're going to do is actually look at the QRS complex that falls on a heavy line on the strip, and then count the number of large boxes between this R wave and the next R wave. Then you're going to divide this number by 300. So for instance, I don't really have a good complex that falls on a thick line. So this one's probably the closest, and there's only one box between this line, and there's only one box between this line. So we're going to say that this one's falling on this line. So I've got 1, 2, 3 small boxes between this R wave and this R wave. So what I'm going to do is take 300 and divide 3 into 300, and that gives me a heart rate of 100. Now, if I use my 6-second method, I'm going to count, and this is 6 seconds because I've got 3 seconds here and 3 seconds here. That gives me a total of 6 seconds. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that also gives me a heart rate of 100. So my R to R gave me a heart rate of 100. And my 6-second method gave me a heart rate of 100. Now remember, you can only use the R to R method when your rhythm is regular, which is what we're going to talk about next. So heart rhythm, step 2. So our first step was heart rate. Our second step is going to be heart rhythm. And this is going to be the sequential beating of the heart as a result of the generation of electrical impulses. It can be classified as a regular pattern or irregular pattern. And what we're going to do is actually measure the R to R interval. Now, this can be done using calipers, or it can be done using a piece of paper. But what you're wanting to see is that, is there a regularity between the R to R? So if I were to take a piece of paper and measure from this R to that R, I'd take that same piece of paper and I would measure over this R to that R, that all the way across, and I would find that this is a regular rhythm because my R to R pattern stays exactly the same. Now, when it comes to irregular, You can have what's called a regularly irregular, which means the irregular rhythms that occur in a pattern. This occurs with things like a PVC or PAC. Occasionally irregular, so every now and then we'll see something come up that interrupts the R to R pattern. Or irregularly irregular, where your R to R intervals show no similarity at all. Now, of note, one important thing to remember with your regularity as well, if the intervals vary by less than 0.06 seconds or 1.5 small boxes on either side, then we can still say that this rhythm is regular. So here's another practice. So if you're following along and you have your outline printed out, what you would want to do is take your calipers and put 1 point here and then 1 point here. Then you would want to flip it to right there to right there, and what you're going to see is that your calipers won't move. They'll stay the same length, and so this actually becomes a regular rhythm. The same thing with this one as well. So next, the P wave, step 3. So step 1 was the rate, step 2 was the rhythm, step 3 is the P wave. This is where we're going to identify the morphology or the way the wave looks. All right, so it should be your first deviation from the isoelectric line. For a sinus rhythm, it should be upright. Now, here's a couple of questions that you're going to ask. Now, you're not going to actually fill this out when you're taking a quiz or something, but this is something that you need to ask yourself when you're identifying the P wave. Number 1, are there P waves? Number 2, are they regular? Number 3, is there one P wave present for each QRS complex, and or is there a QRS for each P wave present? Now, this is going to be an important question to ask when we get into some of our future rhythms. And are the P waves smooth, rounded, and upright in appearance, or are they inverted? If they're inverted, then that means that they're going to be below the isoelectric line or going negative. And then step 5, do all the P waves look similar? So on this strip, we've went through the first couple of steps. So the first step would be our rate. Our rate would be 1, 2, 3, 4, 5, 6, 7, 8. So our rate is 80. Our rhythm, if you're measuring it, you'll see that it is regular. And then our P wave. So what we'll notice is that all of these P waves are uniform in appearance. They all look very, very similar. So what that means is they're coming from the same place of impulse. Most likely the SA node. This is what a sinus rhythm P wave would look like. So the way that I'm going to describe this P wave is that it is present, uniform, and upright, which is all descriptive terms for a sinus P wave.